All right, Bibek, the floor is yours.
Thank you, Professor. Good afternoon, everyone. Uh, can everyone hear me?
Yes.
Okay. Good afternoon, everyone. I'm Bibek Upadhyay. I'm going to present a paper on sentimental liar with my supervisor, Dr. Bibek SentimentalLIAR. We are from Cell Lab, University of New Haven. So let's get started. So what is fake news? Uh, we can define fake news in various forms. So basically, we can say that fake news, we can define it as a news that is basically false, based on its authenticity, whether it is false or not, based on its intention, whether it is bad or not, and whether the news itself, whether it is news or not. Uh, it can also be defined as a fabricated information that tries to mimics the news media content, but in a form, but not in organizational process like as it is usual. So we can tell that a news is a fake news if it is broadcasting information that is intentionally and verifiably false. So why we need to study fake news? Why now? So what's the reason behind the fake news? So we can relate this one with the rise of fake news, since the internet has been growing faster and faster every day as a cheaper means of communication. There's parallel increment in the social network and its user. So the result is that majority of people are now consuming news from social media rather than the verified source. And in social media, both the verified and the unverified news sources can republish their news, which make that the fake news spreading at much more faster speed than the usual news. There are concepts such as naive realism, confirmation bias, narrative influence theory, which are the important factors in perceptron and the sharing of the fake news in social media. One of the example that we can see in current days is the coronavirus caused by 5G. This conspiracy alone has more than 400 Facebook communities, more than 52 accounts, Twitter accounts, and more than 5 million of users have seen the video related to this conspiracy on YouTube alone. So this conspiracy not only propagates in one country, but uh, in more than 30 countries it has been propagated. So this gives the uh, reference for us, like how the fake news is, how one fake news can spread. Uh, but we need to know what's the impact of that particular fake news. Fake news has social political impact. As we all know, in 2016 presidential election and Brexit referendum, the impact of fake news has been seen as a threat to democracy, journalism, and freedom of expression. Um, there is economical impact of fake news claiming that President Barack Obama, being injured in an explosion made a loss of more than $130 billion in stock value. And the more important thing that we need to focus on, the impact that is violence and chaos. That alone, conspiracy theory that 5G caused coronavirus, um, caused the chaos of more than 77 mobile towers being damaged in the UK and many employees being harassed, whether physically attacked or verbally. Uh, Fake news and fake user pages on Facebook also incited the genocide in Myanmar in 2016-2017. So these are the reason, because of these impacts, we need to have an automated fake news detection, and the classification of fake news is essential. So how can we detect fake news? So we can detect fake news in traditional way, where experts and journalists do the fact checking, verifies its authenticity. There are few sources that does this. Snopes and PolitiFact are one of them. But in the era of social media, where the fake news are growing in a large number, it is impossible to do it in a traditional way. Hence, we need to use a machine learning approach in order to identify and detect the fake news in social media. So, but how can we do that? The first thing we need to look into is how fake claims and fake news are different than the true ones. So we can focus on the written style of fake news because they contain exaggerated expression and strong emotions, and they have this intention to convince their audiences to read and trust the claim. There is untouched hypothesis and four-factor theory that says that the fake claims are different from true ones, and the fake statements are expressed with different emotion and sentiments than the truth ones. So combining these two theory and hypothesis, it gives us an intuition that if we can identify the attributes like emotion and sentiments in a claim, then it can help us to distinguish the news, whether it is fake or the true. So we're going to use this hypothesis as the basis to detect the deception based on attribute-based language features such as sentiment and structure-based language features. There has been numerous non-neural network methods such as anagram, part of speech tagging, PC, PCFG for fake news detection. But the limitation is that these non-neural network cannot fully extract and exploit the rich semantic and syntactic information in the news content, which is why we need to move towards the neural network methods such as RNN, LSTM, CNN, and transformers. And speaking of the transformer, there has been a significant improvement in the natural language processing with the BERT, that is bidirectional encoder representation from transformers. It is a state-of-the-art paper in NLP. So the why BERT is really good is because of its applicability in many downstream tasks. So because it has this feature of bidirectionality to look at the words before and after the entities and its content, and we can use the BERT just by tweaking its input and output. For example, the classification tasks can be done by just adding a classification layer on the top of the transformer output for the CLS token. There are two models, BERT-based and BERT-less. We'll be working with BERT-based in our research. We had been working with BERT-based in our research with the transformer layer of 12 and hidden layer of 768. Let's talk about the LIAR dataset. This is one of the datasets that is publicly available for the shortest claim. It was derived from PolitiFact and was done by Mr. Wang in 2017. It is basically 6 levels. You can see the levels over here. So that is fans fire, false, barely true, half true, mostly true, and true. This was further modified by Caroline in the authors by adding the speaker credibility, like which authors has how many the authors count for the false and mostly false and half true. Although for each label there has been speakers credit for all those authors. And in extension to the extended LIAR data set, this is our work. We call it SentimentalLIAR. So SentimentalLIAR is basically the further extended version of the LIAR data set introduced by Caroline. It is a multi-class labeling of LIAR. So what we did is we converted the multi-level in the LIAR data set to binary annotation by converting half true, barely true, answer fire, and false to false, and the remaining to true. Since we only need to determine whether the claim is true or fake, we converted the multi-level LIAR data set to a binary level. We also converted the names, speaker names, to numerical IDs in order to avoid the bias with regards to the textual representation of names. Other than that, we extended by adding the sentiments derived from the Google NLP API, and we also added the emotion derived from the IBM Watson NLP API. The sentiment API, after deriving the sentiment, we add the sentiment whether it is positive or negative based on the sentiment score. There are 5 emotional stages: anger, sadness, disgust, and fear, joy in the emotion states of the LIAR. So basically text, you can see these are the attributes that text implicate, and these are the emotion, and these are the speaker credit attributes. Models, we primarily use 2 models, BERT-based with feed-forward neural network attached to it, and the other one is BERT-based with CNN at the top of it. In the model 1 in BERT-based, we had 2 variants of the model. The first variant, we feed everything into the BERT-base, and the output of the BERT-base is then fed into the feed-forward neural network. And in the second variant, what we do is we only pass the text attributes to the BERT-base, and the remaining sentiment, emotion, and speaker credit concatenating with the BERT-based output, then we pass into the linear neural network. In model 2, what we do is we have the same approach like previous. In the first variant, we feed everything into the BERT-base, then we pass it to the CNN, then we pass it to the linear neural network. In the second variant, what we do is we only pass the text to the BERT-base, Then we concatenate the output of bot base with the sentiment, emotion, and speaker credit scores. Then we pass it to the CNN, and the output of the CNN is then passed to the linear NN. For the CNN, we use two 1D convolution layer with a stride of 1 and the kernel size of 20. The experimental results for the first variant, we can see that if we look into the table, then we only receive the accuracy of 0.6720 with a low F1 score of 0.4021. But after doing this with the help of the second variant, where we feed in the emotion sentiment and the speaker credit score in the by concatenating with the bot output and feeding it to the linear NN, we received the accuracy of 0.6937 and F1 score of 0.5723. So we can see that if we supplement the bot-based output with the emotion and sentiment score, then the accuracy is enhancing than before. So this gives us the reason to explore to the other neural network, which is why we started with the CNN in our second model. This is the experimental result from the second model, bot-based with CNN at the top of it. For the first variant, we received the accuracy of 0.6882, which was similar to the best performance of the model 1. Thus, we keep on playing with the bot-based with CNN. We started with more experiment, and in the second variant, where we passed the text only to bot base, and then when we concatenate the emotional and sentimental vectors with the output of the bot, it yielded us the accuracy of 70% with the F1 score of 64%. So this was the best performing model. So here's the comparison of our work with the past work. As you can see that so bot based with variant 1 and variant 2, 68% and 69% of accuracy were more than the base model accuracy of liars. And our best model with the accuracy of 0.6992, that yielded the 30% more accuracy than the previous works altogether. So why bot-based with CNN perform better than bot-based with NN? So it's because the CNNs are really good at extracting localized features from raw input file, and they also preserve the relationship between them. And when the bot-based with CNN, when we pass the output to the bot-based, a bot is really great at processing natural language text and give the word embeddings, which when we add the emotion vector, sentiment vector, and SPC vector, it just supplemented those input features for the CNN model, which then boosted the accuracy of the CNN model. Both the bot base with CNN and bot base with NN perform well when we add the emotion sentimental vectors. Thus, if we remember the Unde's hypothesis and the four-factor theory, the intuition that the emotion and the sentimental attributes can help to distinguish the fake claims, it can be verified by looking into the observation of our working best performing models. When we add the emotion sentiment to the output of the bot base, it just enhances the accuracy. If we observe to the training loss versus validation loss plot for both our model, we can observe that after 2 epochs, the model starts getting overfitted. This is one of the reasons is the size of the data set is relatively small, and the other reason is when we convert the multi-level liar to a binary label, there's an imbalance of data. Like there are 65% of data that is labeled as false, and only 35% of data that are labeled as true. Also, the results, it verifies that fake claims, we can detect it in cert text based on the exaggerated expression and strong emotion demonstrated in the text. Our code and our SentimentalLIAR datasets are present in the GitHub. This is the link for our code and dataset. The future work is to curate a larger and more representative dataset for cert text claims. The other future work is to work on the knowledge-based classification by extracting the knowledge from the claims and then compare it to the viable source for the verification. We also need to look into how news are being propagated in social network by doing the social network analysis to incorporate the propagation pattern of fake claims and fake news. We also need to look into the user's credibility such that we can identify what are the users, who are the users that are propagating fake news, and based on the user's credibility also we can classify the malicious users and users groups that propagate the fake news, and we can classify whether the news is fake or not. Here are the references. Thank you so much. If there is any question, please let me know.
Excellent job, Bibek. Thank you so very much. So let's open the floor to questions. I have so many of them, but I want you all to try your best to ask as many questions as you can to prepare Bibek for any questions he may have to respond to during the actual presentation at the conference. Nancy? Nancy?
Sorry, I was on mute.
No worries.
Hi, Vivek. If you go back to the slide about how you decided to do a binary classification, right? Was that part of it? That I interpreted that right? You were doing binary?
Yep.
I know you had to, in a way, right, decide what is true, what is false in order to balance the data set. But I'm a little concerned whether or not this would impact the performance of the model, because you know for a lie detector or for this purpose, right, mostly true, where does the data set define the line between difference between mostly true, half true, and this true? Because it kind of gets a little warpy when you try to classify linear separable thing, these classes, which are kind of almost gray in a way.
Yes, true. So the data set that we are working on is with the LIAR data set, right? So these LIAR data set are annotated by the journalist, and the label, the 6 labels that are already given by those journalists to that particular claim or statement based on the amount of the information present on that one. So why we needed to convert these 6 levels to the only binary level is because when we're trying to identify, our whole purpose was just to identify whether that is fake or not. So we had to choose our decision whether we were going to put this half true into the false category or into the true category. So we just looked into the few of the statements, and we decided, so okay, so if it's half true, there might be half false also, so let's not call it true. So that's why we shifted the half true for the false level. And the statements that were mostly true, there were few of the facts that were false in that statement. But if you look into the overall, in the general perspective of that statement, that was true. So hence we shifted it into the true level. And you're absolutely right. Yes, there is a very gray line between those two, but this is just our model in order to identify whether whether that particular statement was true or false. And actually, when we work with this binary level, it yielded more accuracy in identifying. When we were trying to prepare our demo, it identified more with the more accuracy with our validation data set.
Okay. Thank you for that excellent question, Nancy. Do we have any other questions? And I really hope that we do. Okay, so let me fill this silence with a few of my own questions. Vivek, typically when we want to model text, we use recurrent models like LSTMs. Why did you find CNNs more suitable for this sort of data?
So the thing about CNN-R is when you look into if there is RNN, there's always problem with the what do you say, with the I forgot the term. So there is a when we look into the RNN, they cannot preserve the relationship when there is a larger text, right? Right now we are working with the right now, even though we are working with the short claims, our aim is to identify whether that particular news article is fake or not. So our news articles will be larger to length. And so the reason behind to work the CNN are because the CNNs are really good at observing the spatial pattern that one after another. So CNN has been proven at an excellent work in the image recognition in image processing. So when we look into the image is made up of one pixel after the another, and there is a special pattern in that. And we can compare the same analogy over here, because even the text, there is one text after the another text that makes the sense, right? So that is why we are using CNN over here, because it is really great at extracting that spatial pattern. And when the output of the bot was given, it just gives us the word embeddings of the one token after the another token embeddings. So by using the CNN, so it was really good at extracting and analyzing that pattern of text that elicited in the more accuracy than using other models.
Okay, that was actually a very good answer to this question. In summary, if I want to confirm my understanding of your answer, what you said was, well, LSTMs are better for longer running text, but now we are dealing with shorter text like tweets. And for short texts, LSTMs may not be the best choice because the sequence is not long enough. We want to exploit the locality of the relationship between features, and that's what we get from CNNs. Is that right?
Yes, Professor. So we need to look into the both way. Even if uh, if we look into the longer text, then also RNN cannot preserve that relationship because of the vanishing gradient problem, right? So even with the LSTM, if we're only going to use LSTM without the attention, we might not have that much of great results with the LSTM as well. But the CNN, the way that CNN works is it looks into the relationship into each and every kernel, and then identify that and then preserve that relationship that helps us that helps the overall model to uh, to enhance its performance.
Okay, that makes perfect sense to me. Bibi, can you go to your results slide? I think it was slide number 17.
Yes, Professor.
Now, in the comparison table, the green table, the accuracy levels that I see are all below 50%. Does it mean that these classifiers are worse than coin toss? And if so, what's the point of having those classifiers?
Yes. So the problem with this, if we look into this one, is when you look into in the with the respect of pointers, yes, these are less than the 50%. Um, Here's why they receive less than 50% is because they're working with the 6 levels of live data set. So there's always even that. So connecting this with the Nancy problem, this was also one of the reasons why I choose with a binary level classification, because when we try to work with 6 levels and we don't have a great large number of data sets, it's really hard to train that neural network. Because of that, the shorter length of the text as well as a very less available data set in order to train the neural network, it wasn't performing at that great accuracy level. So that was the one major reason. We also tried with the multi-level classification while we were working with our data set, and it did not, it only yielded the accuracy of somewhere around 50 to 60%, but it was not that okay. So which is why we chose to uh, convert the multi-level of the large data set to a binary level.
Okay, Nancy?
Hey Vivek, I just wanted to ask, did you happen also to do the AUC test or the area under the curve? Because I want to generally, I see the F1 score, which kind of helps me
Yes.
with recall and
Oh yes,
precision too.
we did the recall and precision as well. Let me say I do have. I did not put that over here. I was just because I didn't have the
Okay.
recall and precision for other past work. So I just, in order to make the comparison easier, I just kept the accuracy. But let me just share my slide. I had too many collapse. I'm not sure this is the latest one or not, but let me so yep. I'm not sure if this is the one or not, but the recall was somewhere around 0.83, and so the precision was somewhere around 0.74.
And 0 is the true. Is it a false or it's
Yes,
not,
0
right?
is the false.
0 is the false.
0 is the false, 1 is the true. I'm really not sure if this was the latest code, because there are lots of notebooks, but I can look for it and send you the results.
Or Bibek, you might want to include these in your slides in the original presentation.
Okay, Professor. The one reason that I didn't give is because we didn't mention about this in the paper, so I just try to reflect the papers mostly on the presentation. But
I
yes,
understand.
this is the great idea. Yep.
Nancy, what do you think about these values?
I think that I would definitely want to see the confusion matrix first, because obviously seeing some aggregated graded metrics is a little hard without knowing how many samples were used for the test, as well as the balance of the test set in general.
Well, I think we already know that. Bibek, is
Yes.
the test set the same as a training set in terms of the balance?
Yes. So it was. So training set was 80%, then 10%, and 10%. I think that was the number.
And randomly sampled from a distribution of 65% false and 35% true.
Yes. Yes.
Okay. All right. So, Bibek, can you go back to the results slide 17? It's 3 slides before this one, I think.
Yes, Professor.
So back to the question about the green slide. What's the point of having a classifier that performs worse than coin toss?
I think what they're trying to do, I think, after the base model from the Wang. So if you look into the paper of the Wang, he was trying to more focus on the curation of the data set from the pool defect, which can be used as the base data set. So after that, there was the other papers were uh, just enhancing. They were just trying to enhance the performance of the fake news detection using the lie data set. So I think that's what they were trying to work on to enhance the performance of the base model of the lie data set.
Okay. Does anybody have a better answer to this question? I have one alternative in mind, but I'm curious to see if anybody has any thoughts on what the answer to this question should be. Okay. So, Bibek, what's the alternative to automated fake news detection?
It's basically a human annotation by doing the fact checking, whether.
Right. Now, how do humans do in detecting fake news and small claims? When you're scrolling on Twitter, how often do you get to detect whether a tweet is fake or not?
So you extract the fact, the not so called. You extract the basic information from that claim, and you go to a knowledge base and compare whether those two matches or not.
That's how you do it, but that's not the answer to how often.
Oh, okay. So it's based on your memory. It's based on whether you know that thing or not.
Right. The answer to this question is we don't know. Zishan, would you like to go ahead?
Professor, I would say like more or less if you are like it totally based on a perception, like if you have an idea, if you're like if you have your mindset on it, then maybe if you are supporting someone or something, and then it may be like if something news comes out, like if you're reading on a Twitter and post, and if the news comes out it's something like which is against someone, then you think that it is like a fake news. It's totally on the basis of your perception or something. It's not something which I can say that a person can be like compatible enough to say that it's fake news or not. It totally depends either on the state of mind where what he's in, I guess.
That's very true. That's very true. Nancy?
I think what also kind of shows for me with the accuracy is that if, since the data set originally is unbalanced, right? If it was guessing at one particular class, you would see that imbalance reflect in the confusion matrix as well as the accuracy just because of its guessing. But since it's around 50 or less percent, obviously the neural net is trying to make some divisions in the classifications that are not just generally majority based. So there are some things that are the neural net is finding that is, using the distinct between classes, but other sorts of distinctions are not working.
That's a very good interpretation and diagnosis of why those papers ended up with such abysmal results. I actually really like that diagnosis. Thank you, Nancy. Bibek, if I were in your shoes and I was asked the same question, what I would say was, well, uh, fake news is very similar to adversarial examples. They intend to induce misclassification in human brains. Humans typically do not do very well in distinguishing fake and genuine pieces of news, especially when it's coming in the form of short text. So the alternative to automated detection is also worse than coin toss. Probably. I actually haven't seen any studies on this, but based on my experience and understanding of the dynamics of the problem, I believe that the alternative is probably either at the same level of accuracy as these models or even at, at lower levels of accuracy. And also, the alternative is more expensive. Human annotation or human detection of fake news is more costly than doing it using an automated model. Now, even though these models, these previous models, are still performing probably at the same level or better than a human annotator, what we've done is we've made them even more accurate by adding a few more pieces of data or features. Does that make sense, Bibek? And you're on mute, by the way.
Yes, Professor.
Excellent. All right. Now, does anybody have any other questions or any thoughts, any comments on how Bibek can make this presentation better than the excellent level it's already at? Very well. Bibek, you did a really good job. I know you did all the hard work, but I'm very proud of what you've done so far.
Thank you, Professor.
When are you going to record the video?
Most probably tonight, if not possible, then Monday morning.
Okay, please share that with us before submitting it
Sure,
so
Professor.
that we can take a quick look and let you know if something has gone horribly wrong. It's unlikely, but it may happen.
Yes, Professor, understandable.
All right. Thank you very much, Bibek. And thank you everyone for joining us today. I'm going to stop the recording now.